Paper of the day is Integrating Compression and Execution in Column-Oriented Database Systems. It's a 2006 paper. The paper overview commonly used DBMS compression algorithms and show how they can be applied in column store systems. They compare this traditional set of algorithms with compression algorithms specifically suited for column store systems. Through experiments, they explore the trade-offs between these algorithms, varying the characteristics of the dataset and the query workload. They used results from these experiments to create a decision tree to aid the database designer to decide how to compress a particular column. They introduce an architecture for a query executor that allows for direct operating on compressed data while minimizing the complexity of adding new compression algorithms. They experimentally show the benefits of operating directly on compressed data. They illustrate the importance of introducing as much order as possible into columns and demonstrate the value of having secondary and tertiary sort orders. For experiments, they used a combination of synthetically generated and DPCH data. For the experiments where they used DPCH data, they also used columns from the line item factor table at scale 10, which consists of just under 60 million line items. There are three key contributions of this paper. First, the physical database design should be aware of the compression subsystem. Performance is improved by compression schemes that take advantage of data locality. Queries on columns in projection with secondary and tertiary sort orders perform well, and it is generally beneficial to have low cardinality columns serve as the leftmost sort orders in the projection. The more order and locality in a column, the better. Second, it is a good idea to operate directly on compressed data. Sacrificing compression ratio of heavyweight schemes for the efficiency lightweight schemes in operating on compressed data is a good trade-off to make. The optimizer needs to be aware of the performance implications of operating directly on compressed data in its cost models. Further, cost models that only take into account I/O costs will likely perform poorly in the context of column-oriented systems, since CPU cost is often the dominant factor. Now let's give this paper a PS score. Overall, it's a bumpy read due to code, so it gets 6 out of 10 on readability. With 12 pages long, it scores 8 out of 10 on length. Reproducibility shouldn't be too challenging, so it gets 7 out of 10. Industry value and learning is decent, so it gets 7 out of 10 on each. Overall PS score is 7 out of 10.